Alright, in this video we will be factoring polynomials, and we're going to start by factoring by grouping. Anytime you see four terms, the first thing you should try is grouping. So remember, grouping works like this, where you take the first two terms and the second two terms, and you factor out the greatest common factor. I see both of these are divisible by 7b squared. So that's going to be my GCF. So I'm going to pull out 7b squared. See, I knew b squared because of b squared is right here. Now, if I pull out 7b squared, all right, let's see what that leaves behind. So remember, it's basically like I'm dividing. All right, I mean, in fact, that is what I'm doing. So when I factor out GCF, you can think of it as dividing by 7b squared like this, if it helps you, if you need to. So 21 divided by 7 is 3, right? B to the third power divided by b squared is just b. Okay. The b squares just cancel out completely, and I will have 56 divided by 7 is 8. So I have 3b plus 8. That's one way to think about it. Now, we are really hoping that the parentheses over here will also be 3b plus 8. So sometimes I will write it down and just see if I'm right. You know, if I'm wrong, I can always erase it. The GCF here seems to be 3. Both of these are divisible by 3. So if I bring that 3 out, all right, a positive 3, then let's see, 3 times 3b would be 9b, and 3 times 8 would make 24. So it does make sense. So because the pink part is the same, the parentheses, it is itself a common factor. So anytime you have a common factor, you're going to factor it out, put it out front. So I'm going to have 3b plus 8 is basically the GCF now, and I bring it out. That's going to leave behind the blue part, which is 7b squared plus 3. Now, sometimes the leftover part can be factored more. So, for example, if I had 9b squared minus 4, this could factor more, because this would be 3b plus 2, 3b minus 2, the difference of two squares. But that's not what we have happening here. 7b squared plus 3 cannot be factored any further. So that's why this is your final answer. Okay, let's take a look at number 22. Again, when I see the four terms, I think, hey, let's try factoring by grouping. So looking at this first pair, see the a squared? These are both divisible by 5. So I'm thinking my GCF is going to be 5a squared. Okay, so that's going to leave behind 5 times 7 is 35. A squared times a would make a to the third power. 5 times 3 is 15, and then a squared would make the a squared. So 7a minus 3 is what's left behind. So if this is going to work by grouping, this has to be 7a minus 3 again. So I'm going to write that down and then see if I can make it work. Now, here, I will pull out a 2. All right, the common factor is 2. So I'm going to pull out plus 2. Now, 2 times 7a is 14a. 2 times negative 3 is negative 6. So it does make sense. Once again, my parentheses are the same. That means this is a GCF. So I will pull it out front, like I always do with all the GCFs. That leaves the blue part behind. So I'm going to have 5 a squared plus 2 left behind. This with a non-perfect squares, and this is addition, this is not factorable. So this is your final answer for number 22. Alright, so that's factoring by grouping. What else you got? Okay, so now we're going to solve by factoring. Now, the directions just say to factor completely. They don't say anything about solving. So it's really weird that they made this equation that we're not solving, but basically just ignore this part. Alright, because the directions say just factor completely. Solving is going to come later when I get down to this part. So we're not solving right now. So ignore that. So here we go. The first step of factoring is to pull out the GCF. So I see that there's a common factor of x, so I'm going to pull that out. That's going to leave behind x to the third power minus 8. Now I will not stop here. Just like I hope you've learned to recognize the difference of two squares, like if I have x squared minus 16, you know that that's x plus 4 times x minus 4. There's an additional pattern that you need to look out for, and it has to do with cubes. If you have the sum or difference of two cubes, now obviously x to the third power is a cube, but 8 is also a cube. Alright, look at this. 1 to the third power, 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. And 5 to the third power is 125. I could go on, but my point is all of these numbers are cubes because of where they come from. So 8 is a cube. Remember that it comes from a 2. Alright, so this is the difference of two cubes. Now the pattern I'm about to show you works for addition and subtraction, alright, not just subtraction. So here's how it works. For a minute, I'm just going to erase this x so it doesn't distract you. At the end of the problem, I'm going to put it back again. So I've got the difference of two cubes. The pattern is this. The difference of two cubes will always factor as a binomial and then a trinomial, a 2-piece and then a 3-piece. The binomial is going to just be the cube root of each of these. So x to the third power just comes from x, and then I just showed you that 8 comes from 2 to the third power. So that's my binomial. Now if I take these each and I square them, so if I take x and I square it, of course that'll just be x squared. If I take negative 2 and I square it, I'm going to get positive 4. So that's how I get the beginning and end of this trinomial. That just leaves the middle. Alright, the middle comes from multiplying these two together. Alright, x times negative 2 would be negative 2x, but I'm going to do the opposite sign though and put positive 2x. Okay, so speaking of the signs, here's a little acronym to help you remember how the signs go. Compared with the original problem, this sign is always the same, this one's the opposite, and this one is always positive. So we call it the SOAP rule to help us remember the signs. Same, opposite, always positive. Okay, so this is the answer except for one thing. Remember, there was a GCF of x, and that's still here. So this should be your answer, number 23. Alright, so from now on, watch out for the sum or difference of two cubes. Okay, but this is the difference of two squares. So this will just be 2p plus 1, 2p minus 1. I hope you have this down by now. Difference of two squares. Okay. Now, This was on that list I just showed you. 27, remember, was 3 to the third power. And 125 is 5 to the third power. So this is back to the sum of two cubes again. Let me just make sure I'm not skipping problems over here. No, alright, just checking. Yeah, so sum of two cubes again. So again, this will always factor as a binomial and a trinomial. Alright, 27 comes from 3, u to the third power comes from u, and 125 comes from 5 to the third power. Alright, if I take this and I square it, I'm going to get 9u squared. If I take this and I square it, I'm going to get positive 25. The middle term comes from multiplying these together. 3 times 5 is 15, so I'm talking about 15u. But it's going to be the opposite sign, so it'll be minus 15u. Whoops. Lost my parentheses. So remember, compared with the original problem, the signs are same, opposite, always positive. So this looks pretty good to me. Alright, what about number 6? Alright, once again, this is the sum of two cubes. So 216 is 6 to the third power. So that's why when I do my binomial and my trinomial, I will have x plus 6, because that's the cube root. By the way, your calculator will do the cube root if you need it. If I do the 3 and I do second caret, it makes that into the cube root. So if I were to put in 216, bam. I could check and find out that, yeah, that's how you could do it. Anyway, trinomial. So if I take this and I square it, I'm going to get x squared. If I take this and I square it, I'm going to get 36. If I multiply these together, I'm going to get 6x, but I do the opposite sign. Same, opposite, always positive. Okay, I think that's it.